Hey everybody, welcome back. This is part 5 of building a neural network from scratch. And at this point, we have our neural network entirely built, and now we just got to train it. So to train the neural network, we're going to do two things. We are going to first run through the entire feed-forward process multiple times. Now, 10 is way too small, but I'm going to use this as the starting point. We're going to come back and up this later to see how things change. The second thing we have to do is we got to kind of figure out how this learning rate comes into play. Now the learning rate it's important. If it's too high, that's really bad. If it's too low, you can kind of compensate by running this more times. But the goal is really to make sure that these epochs are lower. You don't want to run at 10,000 or 20,000 epochs, because that's the expensive part of doing neural networks is the training. If you have a really big data set and you have a really big network, then these feed forward back propagation steps can take minutes, hours. It can take a long time. The big networks that are done by major companies, some of those networks take weeks to actually train a full network. So for you, the goal in this case is just to try to play around with it to get it to be reasonable. And with a small network, everything's going to train in a matter of seconds, so you don't have too much to worry about. But later on, when you start dealing with bigger and bigger data sets, you're going to have a lot of problems. So let's actually go into how we figure out how good our network is. Now, I can run this right now, and it will go through and do these 10 steps, feed forward everything, all 1,100 samples through one time, back propagate them, and so on. But we don't really know how accurate the network is until we use our test data to check it out. So how do we use the test data? Well, for the test data, we want to set our input to be equal to the testing input. And then we want to feed forward the entire neural network and no back propagation. We're just going to check. We're going to put all of these in, and we're going to see what our network predicts. Because what the network is doing, what the output will be the prediction for the network itself. Now, if I look at the output from this, I will get these values here. So what do these values mean? Well, these are the predictions, whether 0 or 1, for the given input. So in this case, these values that are getting closer to 1 are saying that the banknote that we're looking at, it's more likely that it is real than it is fake, or it's more closer to 1 than it is to being 0. If I run this more, maybe 100 times, what you'll actually see is these values start to spread out a bit more. So this is getting closer to being 0, while this is getting closer to being 1. And there's still some values that are in between, like this 0.6 and 0.3, that are not quite as accurate as these others. If I keep going up higher, this is predicting that this banknote is 0. This is predicting this banknote is 1. And if I go up, say 10,000, just for grins here, we get numbers that are clearly close to 1 and clearly close to 0. Now, these are the predicted values. That doesn't mean that they're actually accurate, because to know that they're accurate, we have to look at the expected value. These are the real values that were given to us. These are the values that it actually is, if it is actually real or not real. So what we have to do is we have to compare this output to the input, or to the expected output. So this output is going to be compared to our expected values. And I'm going to use an absolute value here, just to make this so that all the error values are positive. And I'm going to run this again, and you're going to see that these are the error values. So this is not saying it's close to being 1. What this is saying is that this prediction is way off. The error value is really high. This error value is really low. So this one, whatever it's predicting, is actually not close to the real value, while this one is getting closer and closer to the real value. And then if I run 1,000 times again, you see that most of the error values have kind of come down. The network has adjusted the weights so that almost everything is getting close to being zero. We want it close to zero because when the error is close to zero, it means it's more accurate. This here is much more accurate than, say, this one. Okay. So how do I determine if it's accurate enough? Well, to know if it's accurate enough, you actually have to set a value. So I'm going to set a value in this case of 0.01. So that says that if the error is less than or equal to 0.01, then it is accurate enough for me to determine if the bill is real or not, if the banknote is real or not. So what I need to do now is I need to actually check all of these values in here to see which one is accurate enough for me to determine, with a high enough accuracy that it's a real bill or not. So I'm going to take this as my result. And this result is just the same list of error values here. And what I need to do is I need to count these error values. So I'm going to go ahead and I'm going to make correct count here. And the correct count is going to be, this is kind of interesting. So this is a special thing you can do with NumPy, is you can take the list and you can take the same name of the list here and you can find all of the values that are inside this list that are less than, in our case, the threshold. So this is saying take the list of errors, which we have here, find all of the errors that are less than or equal to this threshold of 0.01. So all the values here that are less than or equal to to less than or equal to 0.01. And what I'm going to do is I actually want to just count how many of those there are. So I'm going to use length, and then I'm going to say incorrect here. Actually, let's not use length. Let's do this. We'll use size. Okay, and I'm going to do the same thing for my incorrect values, but I'm going to say is greater than the threshold, and I'm going to say dot size as well. Okay. All right. So what I'm going to do now is I'm going to print all this stuff out. So I'm going to say correct, and I'm going to say correct here, and I'm going to say incorrect. Incorrect. And then I'm going to print out a percentage for this. So I'm going to say the correct divided by the correct plus incorrect, and I'm going to multiply that by 100, so it's a percentage. All right, so let's walk kind of through what I did here. I have taken the results, which are these error values, and I've found all the ones that are a low error. In my case, I'm considering a low error to be below 1/100th. And anything that is not a low error, which is higher than 1/100th, is considered incorrect. Everything else that's lower than is considered correct. And then down here, I just go ahead and calculate the percentage of correct ones. So if I run this, I get about 10% accuracy, 26 correct, 246 incorrect. Now, if I set my threshold up a bit higher to say 1/10, I'm going to get a much higher accuracy. But I want a high threshold. Or what I want is meaning a threshold that allows not very many errors. I don't want to say, that's close enough. I want something that has a very low error value. So let's go ahead and run this a few more times though. If I've got 1,000 here and I'm getting lower accuracy, I'm going to run this 5,000 times and I get only 21% accuracy. Still not really great, right? So, I could keep doing this. I'll just go ahead and up this to 15,000. And what you're going to find is this is going to go up and up and up. But that's not really working. I'm going to have to increase the number of epochs way too many. So I'm only getting 25% accuracy. So what's the other thing I can change? The learning rate. So let's go up here and change our learning rate. And let's just bump this up to 1/100th here. And what you see is the accuracy jumps up a ton. It actually jumps up. So now if I run this multiple times, and remember I'm getting different values because my weights are random. I run this again and again, I'm getting around 70 to 80%. So let's bump it up again. Let's see what happens. All right, now I'm getting 95% accuracy, way higher than I'm getting before. If I keep running this multiple times, I'm getting 97, 99% accuracy. And if I bump this up to 10,000 epochs, I'll probably get something that's pretty high. Yeah, it looks to be about the same as 5,000 epochs. Now you might be tempted at this point to say, hey, well, if bumping it up to 1/10 is really good, let's bump it up to 5/10 and see what happens. And boom, there. What just happened? All of a sudden the accuracy has slipped down to 50%. And this is what I was talking about earlier with adjusting the weights slowly. If you set your learning rate to be too high, you're going to end up with the network adjusting the weights too much at each epoch. So every epoch you adjust the weights by a really big chunk as opposed to a little chunk at a time. So the learning rate, the number of epochs you're running, this is all kind of the art of neural networks. In our case, we're just going to keep it at 0.1, and I'm going to be happy with my 96% accuracy for right now. What I'm going to say to you is go ahead and play with this. Adjust the threshold. I mean, if I adjust the threshold up a bunch, I'm going to get a much higher accuracy, obviously. But if I adjust it down, oh, look at that. I got lucky on that one. So play with the threshold, play with the learning rate, play with the number of epochs, play with all of these different things in here till you kind of get a good idea of how stuff works. Now, as I said before, the underlying math, that's important to understand, but I think that's something that will definitely come more with time. If you're playing with these things, you'll get the intuitive understanding of what's happening by playing with the actual stuff, and then later you can look at the math and it'll make more sense on why you did that. Okay, so they do work together, but for right now, just play with the tool. Maybe go find another data set that has a 0 or 1 output and try to plug it in here. Change the number of hidden layers, number of nodes in the hidden layer or something like that to see how much it changes the accuracy of the network itself. There's lots of things you can play with in here. All right, if you have any questions on anything in particular, go ahead and ask them below in the comment section. But that's the end of the series. I hope you enjoyed it, and we'll look forward to doing something similar with Keras in an upcoming series. All right, thanks for watching.